All right. Good morning, everybody. I'm going to be talking about the fundamental theorem of calculus today. This is a pretty big one. So we just got done talking about Riemann sums, which is talking about estimating the area underneath a curve using basically rectangles and trapezoids. The fundamental theorem of calculus basically takes the estimation part away from it and makes it all basically finding the exact value underneath the curve that's bounded by the x-axis. So to break it down, the official definition of the fundamental theorem of calculus is which is what you use to find the exact value. If f of x is continuous on a closed interval from a to b and a differentiable on an open interval from a to b, then the integral from a to b of f of x dx is equal to f of b minus f of a, where f of x is the antiderivative of f of x. All right, so it gets into some examples here, and I'm just going to talk about the examples because you guys got this stuff already been posted. So looking at the first example, it says find the integral from -2 to 1. So that part right there is talking about, let's find the area underneath the curve from -2 to 1. So they bracketed out right there from -2 to 1. So and what they did over here is they just found the area as if it was a trapezoid, which it is. The area of a trapezoid would be 1/2 the height times the length of the two bases. So the length of the two bases are 7 and 1. And then the height of the trapezoid is 3. So the area underneath that curve bounded by the x-axis is 12. If you just use a formula of a geometric figure. Using the fundamental theorem of calculus, we would first have to find the antiderivative of -2x and 3, which they do. -x squared plus 3x plus c. And then notice the notation that's here to the right. Basically just a straight line, and then with your integral limits there from -2 to 1 afterwards. So you're always going to plug in the larger number first, whatever number's on top. In this case, it's 1. You're taking 1 and you're plugging it into your derivative. And then you have minus, and then you're going to take -2 and plug it into your, not derivative, but antiderivative. Now, it's a big thing here. The big key is when you have the f of b minus the f of a, you really have minus, and then the second part of that is all still in parentheses. So that way you make sure you don't mess up any negatives. So the big thing you probably see in here is we end up with c minus c, which is going to cancel. That's going to happen on every single problem that you do. So really from here on out, you really do not need to write plus c, because the c's are always going to cancel out no matter what, because you're always going to have plus c in one, you're going to have plus c in the other, but then you're going to be subtracting one from the other, so you end up canceling out. But notice that my answer here is still 12. It's exactly the same answer. Going down here to this next example, basically exactly the same thing, just changing the integral limits. So in this case, we're looking from 2 to 5. Notice here when they use the area of a trapezoid again to find the area, the lengths of the bases are -1 right here and -7. So when I add those up, it's -8. And then multiplying it by the height and then 1/2, my answer is -12. And just notice here that the area, all of that is below the x-axis. Now the integrals up here, the actual fundamental theorem of calculus is basically exactly the same. We're working with the same problem, but instead I had to plug in -5 and then minus, then you plug in 2. And we get our answer to be -12. So really that's not going to change with these next two problems here. We see the answers end up being 0. I have exactly the same triangle above the x-axis as below the x-axis. So if this area is all positive and then this area is all negative, they're going to cancel out and it's going to equal 0 because they're exactly the same size. You can see that happens when we use the fundamental theorem of calculus. When I plug in 4 and then when I plug in -1, everything cancels out and it equals 0. So I'm going to move down here to the next page. Just kind of going over some 4 basic concepts here. If, or basically this first thing is the fundamental theorem of calculus. The integral from a to b of f of x is the area of the region bounded by f of x and the x-axis. So 3 things you probably noticed they are going through those examples. If your area or your answer to your integral is greater than 0, the larger region is above the x-axis. So most of your area is above the x-axis, making it greater than 0. If your answer to your integration problem is less than 0, the region bounded by f of x and the x-axis below the x-axis is larger than the region above. And then if it's equal to 0, your 2 regions from the top and from the bottom are exactly the same, and they end up canceling out, which makes it equal to 0. So we get into some examples here. I'm just going to talk about the examples. Decided today I'm going to try to make this a little bit quicker note session than the last couple. 38 minutes is a little long, so try to get through these a little bit quicker just using the answer documents already. So here the integral from -1 to 2 of 2x minus x squared. So first thing we'd have to do is find the antiderivative of 2x and then minus x squared. So I'd have 2x squared over 2 minus x cubed over 3. And then there's our term limits. Come here, Carter. You want to say hi?
To him. Hi.
Okay, now go. I'm working. Go.
I'm just going to sit here.
So the antiderivative, kind of clean this up a little bit. 2's cancel out. We end up with x squared and then minus x cubed over 3. And then all we have to do is plug in 2. And then minus, plug in -1. And then there's our answers down there. This next one here to the right, the integral from -2 to 3 of 1 over x squared plus x dx. When you find the antiderivative, we get x to the -2 plus x. But the problem is this right here, it ends up being not continuous. Because if you plugged in 0 right there, it would make it not continuous, which is in between -2 and 3. So in this case, it does not exist, and we can't really get the area. Because if you think about what a graph would look like, just here's like 1 over x, just example. Here's 1 over x. So if I was trying to find the area from like here to 0, there's no way I could find the total area because this line's going to get closer and closer and closer to the y-axis, and I would never actually find the actual area. Let me erase a little bit. These other 2 examples, pretty straightforward. You're just finding the antiderivative and then really just plugging in your term limit. So 1 and 4 in this case. So what I had to do here first, 2x divided by x squared would be 2 over x. And then I'd have plus 3 over x squared, which is where they got that answer from, just rewriting as 2x to the -1st plus 3x to the -2nd. So just keep in mind, anytime we have x to the -1st power, when you find the antiderivative of that, you need to go downstairs. Go. Just keep in mind that 2x to the -1st power, anytime you find the antiderivative of x to the -1st power, that is going to involve the natural log. So now it's just a matter of just plugging in 4 right here, plugged in 4, minus, plugged in 1, and then the one thing that might have showed up in this problem that we might not remember is the natural log of 1 does have an answer. It's equal to 0. Which is where that answer right there came from, the -0 part. So we're going to leave our answer in terms of the natural log. So 2 natural log of 4 plus 9 over 4, and that's our answer. This next example over here, antiderivative of 2x is x squared. Antiderivative of cosine is sine of x. And then it's just a matter of, all right, let's plug in pi, minus, let's plug in 0. And then simplify, and we get pi squared is the area that's underneath the curve from 0 to pi of that function. And then the last page of the notes here is basically just using a table of values answer the questions. So number one, what is the value of the integral from -3 to 1 of f prime of x? So the derivative of, or the antiderivative of f prime of x would be f of x. So this would really be, we're looking at f of x going from -3 to 1. So you plug in 1, that's where they get f of 1, minus plug in -3, there's f of -3, and then there's your answer, -6. Question number 2, what is the value of the integral from -1 to 3 of f prime of x plus f double prime of x? So the antiderivative of f prime of x is f of x. The antiderivative of f double prime of x is f prime of x. So then it's just a matter of plugging in our answers, plugging in 3, not our answer, plugging in our term limits, plugging in 3. So I'd have f of 3 plus f prime of 3, and then I'd minus, plug in -1, so minus f of -1 plus f prime of -1, and you just get these answers from the chart up here. Right here, what is the value of the integral from 1 to 5 of 3 f double prime of x? Well, the antiderivative of 3 f double prime of x is 3 f prime of x, and then we're just plugging in 5 and 1. And then the last one here, a couple more. Number 4, same thing. What is the value of the integral from -3 to 3 of 1/2 f prime of x plus 2 f double prime of x? The antiderivative of 1/2 f prime of x is 1/2 f of x. The antiderivative of 2 f double prime of x is 2 f prime of x. And then it's just a matter of plugging in 3 and then minus plugging in -3 and then getting your answers from the table. All right, so question number 5. What is the equation of the tangent line to the graph of f of x at x equals 3? So 2 things that we need to know to find the equation of the tangent line. We need to know the point of tangent C, and you need to know the slope of the tangent line. So f of 3 is equal to 1, f prime of 3 is equal to 3. So here is our equation of our tangent line. So number 6, use the equation of the tangent line in number 5 to approximate the value of f of 3.1. Is this an over or under approximation of f of 3.1? So first thing we're going to do is we're going to take 3.1 and we're going to plug it in for x. So 3.1 minus 3 is 0.1, 0.1 times 3, and then I'm going to add 1, and our answer is 1.3. So the next thing is this an over or under approximation of the actual value? So we have to think in this case about our concavity. Is this function going to be concave up or concave down when x is equal to 3? So in this case, we can just look at the table. The table automatically tells us that f double prime of 3 is equal to -1, which is less than 0, which means it's concave down. So I'm going to draw a picture here. And it doesn't necessarily mean that it looks exactly like what we have. I just know that my function is concave down at x equals 3. Okay, so here's x equals 3. It's concave down. Here's the actual value of f of 3. Here's what my tangent line would look like at f of 3. Oop, I missed it, but you get the idea. I'll just make my dot bigger. So if I go just to the right of 3, say like right here, I'll be looking at just to the right of 3. Is that an over or under the actual value of what I'm talking about at 3.1? So since it's concave down, my tangent line is going to be on top of it. So this would be an over approximation because my tangent line is above the actual value. That's why we're talking about concavity with this problem. It's because it really matters of if it's concave down, it's going to be an over approximation. And then if I had a problem, let's say we're looking at right here, and my tangent line went like this, okay, just to the right of this, my tangent line approximation, because this is what we're using, would be under the actual value because it's concave down. My tangent line would be below it. So that's basically all of the notes today. Got through that a lot faster than normal. So what you guys need to do, I talked about it in the classroom notes there. There's a couple of things that you guys will have to do. Nope, not that. You guys will need to do, I can't scroll down to it for some reason. You guys will need to do day, I believe it is 49 homework and the next 2 free response questions that are on there as well. Come here, Owen, you want to say hi? Say hi. Say hi. Can you see yourself? Yeah. All right, so that's it for the day, but do that day 49 homework and those 2 free response questions. And then send that to me some point on Friday would be good. On Friday, I'm going to be posting the next section of notes as well. Actually, no, I take that back. No, I do believe that's correct. I'm going to look here. Oh, yeah, it's his Lightning McQueen car. On Friday, I will be posting the next section of notes, and then we can go from there. Basically talking about properties of integrals. And then after that, we're basically done with this half of the unit. So same thing. If you have any questions, just email me. Hope you guys are doing good. Staying safe.